Hello everyone, this is Katish here. In this video, I'm going to go through the AQA Physics Paper 1, Paper 2, IIT from 2025. Question number 5 is on the topic of forces. In a world record attempt, a skydiver jumped from a height of 40 kilometers above the Earth. Figure 6 shows an incomplete free body diagram for the skydiver a few seconds after the start of the jump. The skydiver has not reached terminal velocity. Complete the free body diagram in figure 6 now. Because he has not reached terminal velocity, the arrow, it should be a straight line going from 0. Let me redraw that. So going from up, and it should be smaller than the weight arrow. And for 2 marks, you have to label it. It should be labeled as drag. If it was at terminal velocity, then the drag arrow will be the same length as the weight. During the first 2.5 minutes, the mean acceleration of the skydiver was 0.64 meters per second squared. The initial velocity of the skydiver was 0. Calculate the velocity of the skydiver 2.5 minutes after the start of the jump. So they want the final velocity v. Initial velocity u is 0. Acceleration is 0.64. We have the time in minutes. So let's first convert the time to seconds. So 2.5 minutes multiplied by 60 would give me 150 seconds. That should give me a mark. Now acceleration equals change in velocity, final velocity minus the initial velocity divided by the time. So for you, right, so let's substitute it first. 0.64 equals v minus 0 divided by 150. So v equals 0.64 multiplied by 150. That would give me 96 meters per second. The skydiver accelerated until reaching terminal velocity. Explain why the skydiver reached terminal velocity. Now, during terminal velocity, if I redraw the free body diagram, drag and weight, both these forces are acting in opposite directions and they are equal to each other. So there's no net or overall force on the skydiver. So explain why does it happen? Because as he's accelerating, the air resistance increases or drag increases from 0, and once it's equal to the weight, you will reach terminal velocity. So here's the answer for it. As the skydiver's velocity increased, the air resistance increased until the air resistance was equal to the weight of the skydiver and in the opposite direction. Bring that back. So the resultant force was 0 and the acceleration was 0, so the velocity was constant. Explain why the atmospheric pressure acting on the skydiver increased as the skydiver fell. Now, atmospheric pressure is due to the collision of the air particles on the skydiver. As he's falling down, the density of the air around him increases because air is more denser near the surface of the earth. So as he's falling through, density should increase because there's more collisions between air particles on the diver as well. So here's the answer for it. The density of the air surrounding the skydiver increases as the skydiver falls. There are more frequent collisions of air particles with skydiver, so the pressure increases. The skydiver opened his parachute. A few seconds after opening the parachute, the resultant vertical force on the skydiver was 240 Newton upwards. So the wind caused a resultant horizontal force of 200 Newton to the left of the skydiver. So if I start like this, upwards 240. Now this would be to my right, so this should be to my left. That's 200 Newton. Draw a vector diagram to determine the resultant force of the skydiver. Now you could, or in the exam you would actually use your ruler as part of coming to the answer. Here I'm just going to use the grid. We make this a bit smaller so you can see all of it. Oops. We get the marking scheme out of the way. There you go. Right, so I start it here. So I need to go up 240 up and to the left 200 Newton. So if I count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to here. So if I draw a straight line, it does turn straight. Let me redraw that. There you go. That would be 240 Newtons. So each box is 20. Then you need to count 10 boxes to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to this point. Now, I would need to connect from this point to here. Point was nearly straight. Oops. Oh, right. So it has to be that point, and you could use a ruler to measure the length from this point, from the origin to all the way up to here. Now, could you use Pythagoras theorem here? I wouldn't use Pythagoras theorem. That's why they have given us the grid or the graph. 200 Newton, and when you do measure it, it should be within the range of 300 Newton to 320 Newtons in length. So if this was from here to here, if this was 1 centimeter in your graph paper, from this point to this point, it should be about 30 centimeters. 30 centimeters, which means the graph paper is probably not going to be big enough. So, but you should be able to use the ruler to measure that. So the magnitude of resultant force is 300 to 320 Newton, and you should be using a protractor to work out the angle to vertical of resultant. So it will be that angle, and that should be within the range of 38 degrees to 42 degrees. That brings us to the end of this question. Thanks for watching. Apologize for it being a bit slow. Just want to make sure that it was correct.